Welcome to this class. In this class, we will discuss about the packages. In last class, we have discussed on modules. So we can import the functionality of one module to another module using import, and there are several ways which we have discussed in last call. So here, these are the ways. Now today we will be discussing on packages and what exactly package is, how we create it, and what is the use of the packages. So if you see here, in last class also we have discussed about the project layout, and if we see, this is a sample project layout where we have my ML project, and this project will contain several files and couple of packages. So if you see, this is the source package, we call it package. Why we call it package? Because there is a init file, we have to initialize the package here. So now let's create one sample package and I'll showcase there, and then we will discuss about the standardized one. So here I have opened one Git repo for OpenAI Python code, and here we will discuss how exactly a real application is being structured. So let's create a folder here. I'll say src source folder, and in this folder I'll create one file. So let's say the file name is um, data.py. Now I'll write something here, some couple of codes. Let's say def generate, or I'll say load data. So which will return a list of 1, 2, 3, 4, 5, right? Then this module is inside the source folder. Now in this folder, I want to use this load data function from data module into, let's say, my second module py. So if I say like this, import, or let's say import data. So because my module name is data here, and if I say data.load data, then see the output, it returns an error. Where it return? One second, this is not that error. Let me just comment this section. So now let's suppose if I'm importing that, then it says data no module name. So there's no module name data here because we have just simply created a folder and we haven't initialized it. So whenever you create any package, you need to initialize this first. So to initialize it, we need to create one file called init file. So double underscore init double underscore dot py. This is fixed. So whenever you convert any folder into package, you should create this file. Now this is to initialize your package. Then now let's suppose, now if I'll go to here, so this can be one package, source is one package, and within the source we can have sub packages. For example, if we take this one, so if we take this example here, so source package is containing data, sub packages, models, trainings, utils. So I'll create these three or four sub packages here. So what I'll do within this source, I'll create folder called data, and then I'll create another folder called training, and then I'll create another folder, let's say, uh, so let me just create the folders first. So I'll put this data file into data.py. I'll move it here and I'll make this data as a package again. So within this data, I'll say underscore underscore init double underscore dot py. So now data also become a sub package of source package, and these files reside into data sub package. Similarly, we'll create more packages. So here we have one more package called models. So let's say randomforest.py. So if I create one folder again within source models, and in this models, I'll create one file double underscore init double underscore dot py. Now we can create one training file also, sorry, the training for package. Before to that, we can create a model file. Let's say randomforest.py. This file will have some function, maybe def apply random forest algorithm. Similarly, we can have a different package. Models is done, training or utils. I'll create utils. So let's say again, I create one folder utils, and then you create one init file here. So init.py to make this folder as package. And within that, there can be multiple modules available. Let's say my utils.py. And this utils.py can have many functions. Let's say def, um, maybe print values, or we can have more def, calculate mean, maybe or more def, calculate median, something like. So these are the util functions which can be used anywhere. So now if we see in overall the structure of this project, let me just close this. So within source package, we have different packages, data, models, utils. Now, let's say if we are writing any code and we want to use any of the module with residing into package, we can use that. So let's say I'll create one file here. I'll say main.py. So don't confuse it, just I'm naming it. Just a naming, that's all. So don't get confused. It's not main means not main. So let's say main.py. This file can be an initializer or the caller for all the modules. So what I will do, I will just start load the data first. So to load the data, I'll say from source dot data, right? So we are moving into source. This is my package dot next module. So source dot data import data. So if I say like this, data dot load data means we are loading this function here. So if I run my main.py now, it will return the exact data now. So now if you see, the structure is like this. We are calling it from main, but my actual package resides, or my actual module data.py resides within data package. Now let's suppose once I loaded the data, now I will apply some model here, random forest, right? So what I'll do in my main file, I can call that, I'll say from source.model random forest. So random forest dot apply random forest. So we are able to use that. And then there are a couple of utils available here. You can use that as well because this is also another package. So again, like this, from source.utils, my utils dot utility function. So let me check what are the available functions available. Here we have print values. So we can parse maybe let's say I'll just store this data into one variable var1 equal to data.load, and this var1 can be passed into print values like this. So if you run this program, see the output. So we are able to use different modules resides into different packages. So this is the way whenever you create a package or like if you want to package it in like it depends on the domain of application. For example, if I go here, if you see OpenAI Python code, this is the library, and here we have source. So within source, this is a package, and within this package, there are multiple packages available. So for example, we have auth. In auth, what exactly file is written? Workload.py. Similarly, we have CLI. So this is again subpackage of source. So here we can have lot of files here if you see. So each package is having subpackage and again subpackage. So like that. So you can create paths and you can structurize your complete project in this way. So my recommendation for best practices is you take any standard library, Python library, such as OpenAI Python or maybe Gemini AI is also there. Gemini Python lib. We'll go to Git. So if you see here, we have Python Gen AI library, and in this library we have lots of Python files available. There are some packages, interactions. So depends on your nature of the application. You can design your application or structurize it into different ways. But I would recommend you to go through any of the package which is already available open source, and you can get the idea, okay, how we should structurize it if we are developing from the scratch. Keep it simple and separate based on the use cases. Like similarly here, we whatever related to data work, you can create all the modules within this data package. If you have lots of models to apply, like random forest or anyone, you can create different modules here. Utils can reside here. So it's up to how you are structurizing your entire project. It should be easy to understand, readable, and accessible. So all these are the uh, parameters. So if you see here, importable, testable, and shareable. And one of the package you will see in all of the available package is test. So you can create one test package within source, which will be the test file of maybe load data. Let's create it. So I'll create one package within source test. Now in this test, I'll create one init file to make it uh, a package. Now, so what I will do, I'll write a test case for maybe this one load data function. Right. So you can use unit test for that, but I will leverage here Copilot. So I will recommend you to start using Copilot because now you have clear idea, you have created a structure. So now what I will say is write the unit test for data.py, and in test in test package. So if I say like this, so you will get the unit test covered. So we have one function here. You can maybe in future you will be having n number of functions or properties defined here, and we want to do the code coverage. So you can ask Copilot to do that. So before Copilot or AI, we used to write it manually. So now if you see here, the test data file been created in test package, and now it uses a unit test. So unit test is the um, inbuilt, or I'll say internal library for writing the test cases. And this is the way how you write the test case. So if I run this file, so just it will create a virtual environment and then it will run it. But yeah, so what we are doing is expected. This is my expected output, and actual output is returned from my load data function. And we say self dot assert equal means we are comparing the actual output versus expected output. So if both are matching, then our test case gets passed. So this is how it works. And this is a command to run the unit test here. And unit test source.test.test data. This is your module name and minus v. So once you run it, you see the output. So unit test case has been added and verified and passed. So one test run, all passed. Okay. So like that, you can write more coverage to all of the models or all of the modules available in your package or throughout the project. And you can generate a test coverage file as well. So you can ask Copilot saying that generate the code coverage summary or that file, HTML file. So it will leverage the unit test capability and will create it. So this is the overall structure we have created. So what we did, we created one package called source package. So when we created this folder, src folder, to convert this folder into package, we created init.py. This is the file. So this is mandatory step. Whenever you are creating any package in Python from folders, you should create the init.py file. That was the first step we have done. Now, after that, we created data, models, test, and utils. These 4 folders. Now, to convert those folders into package, we have to create init.py within data, models, test, and utils. In all these 4 folders, you need to create init.py like this. Init.py, init.py, init.py. I have to expand it. So this, it is also available here. So once you created init.py, then these packages are ready to use. Now, within the data, now you can create n number of modules. So I have created one module called data.py. It contains some code. Similarly, in models, I created another module, randomforest.py. It has some functions. In test, we have test data, and utils, we have some utility functions here. Now, the code is separated and written in each of the sections based on the use case. And outside, I created this main.py file and called the functionality or the code written inside the data or models or utils. So if we go to that code, main.py, so this is the way how we need to import. So what happens here in main.py, now we have imported the functionality. To import the package, this is the way. from is keyword, then you pass the package. And if you have more sub packages, so it goes like that. Package, let's say p1 dot p2 dot p3, depends on how much hierarchy you have created. Maybe inside the package there can be a sub package and then again sub package like that. So you should import in this way from source dot data. So this is my root package, and within this package this is the sub package. So I imported like this. Then I said import data. So what exactly data is? Data.py, your module. So this is your module. This module can be, no, let's say tomorrow you are creating one more module here, m1 dot or m1 underscore data.py, and you want to import it, then you can do like that also, comma m1 underscore data, right? Or you can take in next uh, line also, from source dot data import m1 underscore data. Similarly, I have imported models also, random forest, which is available here. And you can call the functionality in same way, like in the last class also we have done it. Module dot property. This is my property function. Data dot load data. Random forest is my module. Apply random forest is function. Resides into this module. So we are calling that. Similarly, we are calling util functions. So now this is one of the scenario. Second scenario is, let's suppose I want to use any utils in my random forest.py. So here I'll have one function. So I would say from source.utils import my utils. Now let's say I'm creating a function f1 which can use any utils. So let's say my utils dot maybe calculate median. So you can pass like this. Now data equals to my median data, and it returns the median as well. So return median, or I'd say data. Sorry, yeah, data. So now I can call this function. So if you see here, I am using my utils module into random forest model, and I can call f1 here now. Right? So we are able to utilize, or we are able to reuse the code of utils anywhere across your project. So it's not about the the hierarchical way. It's not like that. You have to tell to the compiler that this is my location. You import it from here, and then now it is ready to use. So now if you see, apply random forest, I am already calling in main.py. So if I run my main.py file, so you see here we are able to execute median also. Right? So you can do that. So any of the module can be imported anywhere across your project.